This is a 2007 Chevrolet HHR. It's a fairly decent car. It's got a good motor, but the computer has been vandalized and stolen out of it, so we're going to remove the motor. Let's see. Yeah, the computer was really heavily vandalized, but the motor's good, low miles. It is an ecotec variable valve timing 2.5 liter Chevrolet motor, GM motor, I guess. These aren't real popular, they're not very good motors, but they're in everything, and we have to have one, so we're going to use it. And we just about got the top stripped off of it. We've got the wiring harness laid back, exhaust off. Got to get the heater hoses. We've already got the bell housing bolts out. We got a couple bolts. We got the flywheel bolts. We still like the bell housing bolts. We're not far away from getting this out. When I get ready to pull the motor out, we'll be back with you shortly. Okay, we've got the HHR loose. It had a whole lot more bolts in it than what we expected, but we seem to have gotten everything out of here. I don't have a book on it. We're just kind of playing along. But we've got everything loose. We're getting ready to pull it the rest of the way out of the car.
There's 9 bell housing bolts.
Yeah, there's 9 bell housing bolts.
There's 9 bell housing bolts in it. And then there's a bracket back here on the back side that goes to the behind the axle. You got to take loose, and that's what had us hung up. Right down in there. Now you can't see it, but on the back side of the engine down in here, right behind the strip tire, is 2 bolts you got to take out of the back of the block.
Just about out. We had to take the intake off, of course. Looks like we're clear of just about everything. Hoses are hanging up. And those hoses are gonna hang on this little plastic piece here. We get this up before that oil filter will move away. That way it'll clear it. There we go. Now bring it forward. Hold on just a minute. It's coming out now.
There we go.
Okay, got it. Got antifreeze all over me.
Damn.
A little bit hung back there in it. Exhaust manifold.
Yeah.
We're just about clear up here. We'll be able to move a little forward. Doesn't matter if we damage that plastic because we're not reusing it. There we go. We gotta get it off this plastic back.
It'll come out. We tilted it up. Hang on.
That's all right. It's just popping a little clip.
Damn, you're hung on wire here.
Oh, okay. I didn't mean to be on that.
There's wire in there.
Okay. It's out, ain't it? We just gave birth to a 2.5.
2.2.
This is 2.5. The other's a 2.2. It's done. We'll be back shortly. We've got the 2.4 engine out of the black HHR, and it looks good and clean. It's a low mileage engine. We're going to drain the oil out of it and tear it down. And I guess you may notice this is a VVT motor 2.4. We've also got the engine that failed out of the silver HHR. And of course the timing chain slides all broke, and when they broke it allowed it to go out of time. Let me get a light. And it's hard to see, but you can see right on the back side of the piston that it's busted, hammered really bad. On the front side it is. All 4 valves impacted the piston. And I don't see any damage on the other pistons. We're not going to use this block anyway. This is a 2.2 block, and this is a non-VVT, which are, the heads are not interchangeable, but the blocks are. And originally we were going to use this head, of course, where it's impacted, the number one cylinder, those valves are hammered and bent, and the seats are flattened out, so this head's toast. This is a non-VVT head, but we've still got a good bottom end in this VVT motor. It's a 2.4, and our plan is we've got another head, a 2.2 head, that we're going to pick up and put onto this block. We're going to get tore apart, get the head off of it, and make sure everything on the bottom end's good. Drain the oil out of it. Look at the oil. It's low mileage, but it has been sitting for a while. There hasn't been any leaks. The oil on the side of the block has come from where they've been changing filters. There's no sign that it's been leaking in the front, but it's been sitting a while because there's dirt daubers all over it. We're going to get it cleaned up and torn down. We've got a new water pump, all new timing assembly that we were going to put in the other motor. We'll replace all the timing, put the new head on it, and hopefully we'll have this wrapped up in a few days. Okay, it's been a few days. We've got this 2.4 motor torn down, and it's relatively clean inside. It's hard to see, but it's hard to tell with this light. But you can still see all the cross hatching that was done when the engine was machined. Very little carbon on top of the pistons. These are fly mark pistons, so this 2.4 has just a tiny bit bigger bore, 2 millimeters I think, bigger bore. And also has these fly marks because these are flatter top pistons than what was in our other motor. Our 2.2 has a slightly dish piston. It's horrible. They don't come up as far either. So you're going to gain just a few more cubic inches with this little motor with that 2.2 head on it. We've already taken the water pump off and put all this bracketry for the thermostat and stuff back on, and got the head back from the machine shop. Turns out we were able to use our 2.2 head anyway. It's come back and had all new valve seals, had to replace every single exhaust valve in it, and I think 2 or 3 of the intake valves. So it hammered the pistons everywhere it went. So it must went through a full rotation with the timing chain broken. But we're able to reuse a lot of the rockers and the lifters and all that stuff, put a lot of the old stuff back on it. The cam was in great shape. It didn't have any damage. Lobes aren't worn at all. It's got roller rockers in it, so that usually helps. And started taking this front end apart. Got to take the balancing shafts out and put new cogs on the balancing shafts. There's the water pump. We haven't put the pulley back on it yet. It's a new pump, but the pump we took off of it looked amazing. It's got a really good seal in it. I think that part's made out of stainless steel. It's probably had another 100,000 miles on this water pump. No leaks anywhere. It's in great shape, but we had it in the kit, so we replaced it anyway. Hopefully it'll last a little bit longer. We've got the cylinder head on and the new head bolts. This is unusual the way this thing torques. It torques, just barely torques to 22 pounds, which is not very high, but when you torque it to 22 pounds, you start at 12 o'clock after you go through and torque them all 22 pounds through the torque sequence. You start at 12 o'clock and then you have to turn it 155 degrees, which is from 12 to around 5 o'clock, almost halfway, almost a half a turn to get the yield on them. So you just do 22 pounds to get them seated, then you turn them another 155 degrees, go all the way through and torque it again. And that's what sets these MLS gaskets on these aluminum heads. Something I find interesting about these motors, they're a GM product, but I think Opel may have helped design them. And of course, Opel's never been known for having a good engine of any kind. So this is no exception. These 2.2 and 2.4s are the performance racy little engine. They sound racy. One of the reasons is the flat plane crank, where the crank lobes are 180 degrees away from each other, and they vibrate really bad. Flat plane engines do. I think the new Mustangs may have flat plane engines, but they're notorious for vibrating. If you just left it without any way to balance itself, the flat plane crank would just sling the engine apart. So in this particular motor, they put balancing shafts in. You've got exhaust valves here, and you have an exhaust balancing shaft which goes in here. Over here you have your intake valves. You have an intake balancing shaft, and it keeps everything balanced to keep it from flying apart. It's different than like a regular V8. I have a small block Chevy over here, and they call these 90-degree V8s, but it's not because they're cast at 90 degrees. It's because these lobes, each one of these rod journals is 90 degrees from each other. There'll be a rod journal, and the 90 degrees will be another one, and it goes all the way through the whole process, and they're able to put weights on these to balance these. Some of them weren't internally balanced. The 400 was externally balanced. But I thought it was an interesting fact about these little cranks, the way they work. Let's see. You have your center line of your crank, and you have your lobe over here on your crankshaft that connects to your connecting rod. And 180 degrees from that, you have your other lobe. So you've got 4 of these in that particular crank. You've got 2 on this side and 2 on that side, but it's not balanced in any way. They can be balanced, but the small block Chevy we just looked at, it's hard to see my crappy drawing. You'll have a rod journal, and then you'll have a rod journal, another one, and another one. And these are 90 degrees from each other. And it's a little easier to balance, and it's a smoother, to me, a little smoother. But these high performance race cars you hear going down the racetrack and stuff, like the Indy cars, a lot of those are flat plane. The Ferraris, these high performance cars are flat plane, but they're balanced in some way. They have to be balanced other than just using the crank and flywheel and the damper like the 90 degree V8s. I just thought it was an interesting fact, but it's something we have to work with because we have to put an extra chain on to run the balancing shafts. Now we've got the balancing shafts in. We got the chains and the guides. Slots flooding everything out. You can see we've got the intake pointing straight up to a colored link. Exhaust is pointing straight down to a colored link, and then got our keyway on top. That's our piston at top dead center. So that has a colored link on the bottom, also lines up with a mark. So that's the balancing assembly, and I still like the timing gears and timing chain, but it's getting late tonight. The only thing left to do on this balancing shaft is pull this grenade pin. When you pull this releases an internal spring that holds some pressure on the chain, but it doesn't hold all the pressure. In behind this little gadget, there's oil galleries. That's why oil pressure is so important on these cars. You got little oil sprayers here. There's a little oil port in the head that delivers oil. There's just oil pressure is the main thing. Keep your oil changed on these little 2.2 and 2.4s. You got to keep them cleaned up. But I'm going to pull this pin and that released the pressure on this. And then you can't reset this, you have to take it apart to reset it. But that's the balancing assembly done. This is the water pump. These are the slides and guides that goes on it. These torque to 89 inch pounds, and looks like everything is where it needs to be as far as top dead center. The next part is getting these shafts. This is a new head, so I had these cams out. So to start off with, when you put the cams back in, you put the exhaust cam with your slots, it's hard to see, pointing at 7 o'clock. Your intake side, your slot points at 5 o'clock, and that's just to get the initial setup. Once you put the gears on, you have to make sure that your intake is at 1 o'clock and your exhaust is at 10 o'clock. And we'll talk more about that tomorrow when we put the rest of it together. It's getting late tonight. I'm going to end it here. We'll probably do a 2-part on assembling this motor. So this is just the first part, and we'll get back to it tomorrow. Thanks for watching.